All right, so we're going to spend a couple minutes talking about something called partial quotient division. And what I found is that the kids seem to think this is a bit easier than the traditional way of division that most of us parents learned. But it's different, and it takes some thinking. So I'm going to show it to you guys so that you can share it with your kids and maybe understand it yourselves in case you have to kind of go over it with your kids tonight or tomorrow night or before the test. Just keep in mind it's something different. And really the whole focus of the thing is this word right here, multiples. And so remember, multiples of a number, it's like counting by that number. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So 3, 6, 9, those are multiples of 3. And this method of solving a division problem, it's just all about multiples. That's what it's all about here. So I'll show you what I mean. And what I do and what we did today, so I had the kids divide their whiteboard into thirds, and I had them do it like this. And so let's say we had the problem 86 divided by, let's say, 5. The first thing we did over here was we got an estimate. And now there are different ways of doing estimates. I just try to keep it as simple as I can for the kids when it's a division especially. And so I write the problem again over here. And all I do is I look at the first digit, almost like it's traditional division. I say, how many 5s can I take out of 8? And I can just take 1. And then if there's another digit after that, then I would just put a 0 basically for every digit that follows that. So that would be my estimate. My estimate would just be 10. And so it's going to be off. It's not going to be a really close estimate, but it's close enough to at least kind of check for reasonableness, and that's really what we want. Then I go and I solve the problem. And to solve the problem, draw a line along the side like that. And we did write this in our math journals today. Hopefully they brought that home if you need to be going over this. And again, what we're thinking about are we're thinking about multiples. So just keep that word in mind, multiples. And we're basically going to see how many groups of 5 we can take out of 86, but we're going to be thinking about multiples of 5. And I told them a good place to start, if it's a big number, is start by asking, could we take 10 groups of 5 out of whatever that number is? Because if we can, we want to take the biggest that's the easiest to work with. And 10 just seems like a really easy one to work with. They can use their multiplication charts for these, and that helps. And so I can take 10 groups of 5 out. So, well, 10 groups of 5 is 50. So I'm going to take those 10 groups of 5 out now. And that leaves me 36. Okay, now I've got 36. I can't take another 10 groups of 5 out of 36. So I'm going to use my multiplication chart and get as close as I can to 36 without going over, and that would be 7, right? And so if I take 7 groups of 5 away, that's 35, and I subtract and I get 1. Now 1 is less than 5, so I should be done, and so my answer should be the 10 plus the 7, which is 17, with a remainder of 1. And then in this last box, we checked our work. We took 17, we took it times 5. That is 35. I get 85 plus my remainder of 1, and I get 86. And so the answer, or the quotient, would be 17. There would be a remainder of 1. Let's do one more together, and then I'll let you go. I just wanted to kind of give you an idea about this. Again, I'm going to divide my whiteboard, my working space, into thirds like this. And let's say the problem is 258 divided by 6. Let's just say that. I'm just kind of winging it. I don't have anything written down, so hopefully I haven't created a problem for myself. I'm going to get my estimate over here. I'm going to write my 258. I'm going to write my 6. Well, 6 can't go into 2, obviously, so just like in traditional division, I'll move over. And I can take 4 groups of 6 out of 25. And there's 1 digit left. So my estimate there would be about 40, I think. And now I'm ready for my actual partial product division. 10 groups of 6. I guess I'm going to start with that. And that's 60. And 9. So 8, I get 198, right? I can take another 10 groups of 6 out. I better leave lots of space for working. Well, not too many. 8, 138. I can still take another 10 groups out. And that's 60. And that's 78. I'm getting closer now, but I can still take 10 groups out. That's 60. That's 18. Oh, and it worked out evenly. Boy, that was lucky. And how many groups of 6 out of 18? Well, 3 6s is 18. And look, there's no remainder. Promise, that was just lucky. 10, 20, 30, 40, 43. So my answer should just be 43. If I come over here to check it, 43 times 6, 8, carry the 1, 258. So it works out. So that's how we do partial product division. I'm just taking those multiples, those groups of multiples, out. And now if you had a bigger number, let's say instead of being 258, this was 858, I could go ahead and I could take 100 groups of 6 out first, and that would be 600, and that would make that a lot smaller, right, if I wanted to do that. So I can do that. It doesn't matter what I do. If 10 groups is too much at some point for someone, although 10 should be pretty simple because it's just they add the 0, but all that matters is I'm taking groups away. I may have more subtraction problems here. If instead of 3 I just took 2 away, well then I'd have 6 left over and I'd have to do 1 away from 6. But it doesn't matter. There's no set way. If you knew that 12 groups of 6 was 72 and that was easier for you to subtract, you could have started with 12 groups. And you could take another 12 groups and another 12 groups. And you could do it that way. And you're going to come to the same 43 however you do it. But that's the way partial quotient division works. Just a little different than what we did when we were in school, probably, although I'm getting old enough now that some of you may have actually had this in school. So there it is, if that helps. Hopefully it does.